Hello and welcome to this UniTaster On Demand event today. My name is John Sheik. I'm here from UniTasterDays, and it's my job to introduce the event and introduce our speaker today. With these events, what we try and do is give you more information about studying lots of different university subjects. And I'm absolutely delighted today that the subject we're going to be covering is Actuarial Science. I'm joined by Shaun Parsley, joining us from the University of East Anglia. And Shaun is going to provide a guide to why you might be interested in studying the course, what to expect on it, application tips and careers. With that, I'll pass things over to Shaun, joining us from the University of East Anglia.
I'm Shaun Parsley. I'm an associate professor in actuarial science at the University of East Anglia. And as John says, I'm going to give you an intro into, what actuarial science means and how you can study it at university. So, as I said, today, what we're going to talk about, well, we're going to say, what is actuarial science and who uses it? Then we're going to talk about actuarial science at university and show you the options available to you. And then finally, just for background information, we're going to talk about spotlighting on actuaries. So giving you a little bit more of a background of what actuaries specifically do. So what is actuarial science? Well, actuarial science is a melting pot of various subjects. It's a multidisciplinary subject. It uses skills and techniques from data science, mathematics, business and economics, and computing. And with all that, you bring them together and you solve complex problems for businesses. You are problem solvers with actuarial science. So a couple of quick examples. So here's one. How should an insurance company alter premiums they charge for an individual who uses smart technology to manage their health? So this is for an insurance product and somebody is very conscious about their health and making sure that they're fit and they're doing exercise and they're eating well, and they use this technology to prove this. Actuaries work out how much they should charge that individual. Another one, how can investment fund utilize artificial intelligence to improve their investment performance? So using technology to move faster, to be cleverer. A machine can think about more options and more outcomes than the human mind in a very short space of time. So who uses it? Insurers. Already then talked about that. Insurers love actuarial science. Governments, they need to plan. They need to build big models to plan, how many schools they need, how many hospitals, how many people are going to be state pension age in 2062, things like that. Banks, similar to insurers, they need to project into the future. Pension schemes, once again, very similar again, they're thinking about the future. Fund managers, I talked about investment, so the investment world love actuarial science. And technology firms, increasingly we're seeing technology firms coming up with solutions which involve actuarial knowledge. So is it for you? So quickly, what sort of person do you need to be? Well, you need to be keen to learn new skills. You need to enjoy maths. You need to and be strong at maths. Got to study at university, really. You need to be a problem solver. Work in teams. Very little, but what we do is kind of working on our own in some sort of silo. Usually we're working in big teams, so you've got to want to work with other people. And you've got to want to share your knowledge within a community, because that's how the profession is constantly improving. It's very difficult to be an expert in actuarial science. So you've got to be strong and determined, and you've got to enjoy spending time on computers. So, and careers. So there's a number of traditional careers, and be an actuary. Use an actuarial science. You can, for obvious, the clue is in the name there. You can be an accountant, be a fund manager. I talked about investment. You can be a consultant, a financial consultant, or management consultant, or business consultant. Can be what's called an underwriter. So you work in the what's called the general insurance market and trying to understand and start insurances for bespoke types of products. Can be a broker. If you like talking to people, but also want to use your analytic skills, a balance is being a broker or a financial advisor. As I said, these are traditional areas. Right, now there's new areas. So risk modeler, these things, really thinking about emerging risks, these black swan risks, as they're often called about. You could be a data scientist, data designer, before you actually do your science on data, you can be the person who specifies what data people actually need to make strategic decisions. Process engineer, once again, with the technology, you can start to optimize using actuarial techniques of how processes should work. Everybody in financial services and in all industries really is considering the massive advantages of machine learning, and actuarial science is starting to really get to grips with that. So, lots of opportunity there. And of course, with concerns with the climate, actuarial science is looking to the future to solve problems. And of course, we're all very concerned about the climate. And these are emerging roles, and we're starting to see more and more graduates go into these areas. So, right, onto actuarial science at university. So, in the UK, I'll focus on accredited courses. What that means is that if the course is accredited, it's accredited with the actuarial profession of the UK, called the Institute and Faculty of Actuaries, IFOA, you might see in some of my slides. And what that means is you have the opportunity to, if you do well at university, to score exemptions from some of their professional examinations. And I'll talk about their examinations at the end. So accredited courses, have gone through a process with the IFOA to make sure that they're covering the material which is required to give an exemption for a specific subject or subjects, but also the quality. And often that involves a university employing some actuaries, some past practicing actuaries like myself. I'm a fully qualified actuary to do some of the teaching. So the good news is there's around 20 universities who offer this around the UK now. And, I haven't put a list. It's pretty spread, geographically all round, some in Scotland, there's some in the north of England, there's some in Wales, there's some in East Anglia where I am, some in the south, at Southampton, for example. And you see, I'll put one of these QR codes there. If you scan that, you can go onto the IFOA site, and there's a list of every accredited course on there throughout the world, not just the UK, but obviously I've focused on the UK. So undergraduate, so there's BSc in Actuarial Science, and there's also the integrated masters, the MMath in Actuarial Science. BSc is 3 years, MMath is 4 years. What we tend to see is not many MMaths. There are some around. What they allow is sort of further development in that final year in a specific area. So what we're starting to see is, students are, really enjoying the actuarial science side, and then they want to do, say, a bit more study in data science, and the MMath allows that. And feedback from a number of employers is that the graduates they love are people with a knowledge of actuarial and a knowledge of data science. That's what they're really, really up for at the moment. There's also postgraduate options, which I'm not going to talk about today, but these, there is an MSc, and you can do a PhD. The MSc in actuarial science is 1 year, and ultimately sort of tries to cover as much of the material that you cover in the BSc across 3 years, to give those exemptions as in the BSc. But that's a very intensive course, very enjoyable. PhD, there's not much actuarial kind of research in universities and higher education. Most of the work really is done out in industry, but you can do PhDs in universities. And then finally, most of the 20, most of the university courses in actuarial science offer the year in industry option. This is an incredibly valuable option, and please do look into it. I haven't talked about it too deeply here. I see it as your apprenticeship. That's how I see it. It's a year process. Obviously, it's a year in industry, and it's usually with an actuarial employer, and they get to train you. So you're a year ahead of many graduates. With that, but I'll talk about where that comes in a little while. So what will you study? So I'm thinking about remember I said about the multidisciplinary nature of actuarial science. So there we go, interdisciplinary knowledge, mathematics, you do lots of maths, data science, computing, business, so understanding how the finance industry works and some of the accounting requirements on business, and economics. We actuaries are dependent on a sound knowledge of economics. And as I said, from that, it's potentially you can get 6 exemptions towards being an actuary in the future. But as again, I'll say that about that in a little while. Now, at university, we don't just talk that, because we're a vocational degree. We're a degree which is very focused on a particular industry. We also focus on training you with the softer skills and the things which will help you get into the industry. Communication skills, how to present, how to do written reports to a level which quite frankly your employers will expect. Networking, the importance of working in a learned profession. How to present. Coding, very important. More and more employers talking about they're very keen for their graduates to be proficient in some software, things such as Microsoft Excel, but also in R and Python, languages like that, which are becoming more and more integrated in actuarial science in the workplace, and of course working in teams. Now, another area which is really important and very important, because you are going to go and work in the world of actuarial science, is you've got to be able to think critically. It's okay having all this knowledge, but you've got to know how to use it. So we help train you to use your judgment. We give you situations and problems which you have to think about and be creative to come up with solutions. And finally, we try to train you, and I smile a bit because there's so much is natural, but you've got to have initiative. You've got to be keen, and we want you to be passionate about actuarial science. So there we go. We bring this together, and why do we do this? Well, it's because actuarial science is vocational in nature. So having a broad range of skills is absolutely necessary. Okay, right. So quickly, I won't spend too much time on this one, but this is a timeline of potentially what you would learn. Now, this is based on a program which I teach. So, but but I would imagine that around the country there's not much difference to this. So in year 1, there we go. You do some maths, you do some stats, you do some professional skills. We're already starting to get you to think about what it is to to work in actuarial science. Financial maths, and economics. You learn them. They're absolute cornerstones of our world. So year 2, what do you do then? Well, you build on year 1. You do more stats. We then bring in some accounting and finance. Then you see some actuarial mathematics, which is focused on mortality, which is a key area where actuaries in particular work, but it's still useful for everybody just on actuarial science. But even if they decide not to become an actuary, it's a great topic. And further mathematical methods, numerical methods and things like that. And we start to bring in coding as well. Then some of you will decide to take your year in industry. So you would disappear after year 2 for a year. Some won't, so that isn't relevant, and we'll go straight into year 3. And year 3, once again, we build on them first 2 years. We do more actuarial mathematics. We do actuarial statistics, which involves modeling of data and fitting some, and using advanced probability distributions. Then we do some corporate finance, how firms are structured, financial economics, which underlays a lot of the investment world, and we really ramp up on the professional skills. As I said, that will vary between universities, but I think really you're going to see them elements wherever you go. So if you've done a BSc, you graduate, well done. And I put a year 4 on there. So just if you remember, there are some maths around. So if there is one, the one we've got at UEA, as you can see, we focus on the technology side. So we focus on machine learning and data science in essence. So you would do that, and that's equivalent. You've then got equivalent to a master's, and there you go. You graduate at the end of that year. Okay, right. So what should you expect? So how much time do we spend with you? Well, it's quite an intensive. So it's kind of typically 16 hours per week. That will vary again by university, but that's pretty typical. Actuarial science does need lots of contact. It isn't, in reality, really you can't just go away and read books. That's not an efficient way to learn this. Teaching format is varied. So we have some traditional lectures, we have seminars, computer sessions. So much of our time is thinking about how we model things. So we need computers. And of course, as I said, we're problem solvers. So you get lots of problem sessions. Assessment wise, it's pretty varied again. So you have some exams, but increasingly we're bringing in other ways to assess. So, coursework, of course, but, group exercises and projects as well. I think the whole, everybody, in the higher education sector is a big fan of projects, because it really does get you thinking and working in teams to solve really complicated problems. So then there's some differences between various universities. So that's what this is here. And I've just listed some, this is around what the university will focus on outside those core topics. So some focus on data science, some focus on sort of pure maths, some on the finance side, which is more akin to doing a management, a management degree, that sort of thing, as sort of additional to your actuarial science theory. And some focus on, even further down the technology route and go down artificial intelligence. So 3 application tips. So, it's a very competitive space, actuarial science. So, I've got to help you get into it. So number 1, demonstrate your passion for the subject. We love it when an applicant is passionate and really, really wants to come into actuarial science. So never underestimate how important that is, because, we want students who are keen to learn. Don't be scared to talk about what you've investigated in regard to the subject, and talk about what that's shown you. Show your knowledge of what you already know. It's absolutely fantastic if we have an applicant who, is clear that they really do understand many of the kind of bases of actuarial science. And finally, don't be scared to talk about where you want your career to go. Actuarial science is for ambitious people, talented, ambitious people. And, most of us who teach it, and that does vary by university, but, most of us are actuaries and have had many years working in industry. I worked in the life and pensions industry for 20 years before moving into higher education. So the final part of the talk today is a quick run through on actuaries. As you'd expect, actuarial science and actuaries is got the clues in the name there. So actuaries is where is the profession which kind of launched actuarial science. So let's have a look at that. So what do actuaries do? Well, once again, they're there to solve complex problems for businesses. For example, insurers. As I said, how much should an insurer charge a customer for car insurance? If you go on a website, you'll see a range of premiums to insure a car. And where does that come from? Who comes up with these prices? That sort of thing. That's what actuaries do. The other thing actuaries do, predominantly in insurance, is make sure that there's enough money there to pay the claims. So there's this big focus for actuarial and actuaries on writing new policy, new contracts, new business, and then how do we make sure we've got enough money once we have written it? And another area actuaries work in is pension funds. And again, I mentioned it earlier on as well, making sure, how can a pension scheme make sure that they've got enough money to pay pensions which could be running until 2100 or something now. So that's what actuaries do. They help project those future pensions. So how do you become an actuary? Well, so there we go. The Institute and Faculty of Actuaries, as I said, they have 13 exams that you have to pass. So once you've passed them, you're a fully qualified actuary. Now, I'll go into how that works with the university study of actuarial science. So there's kind of two paths, as that grammatic shows. The first one is that you could do a kind of a non-actuarial science degree, do something like BSc mathematics or economics or something. And you then, when you graduate, you go and secure a role at an employer. And then you take the 13 exams. Can you remember I said you needed to pass 13? And that typically takes you between 5 and 7 years. Now, another route is if you go and do an actuarial science degree, a BSc or an MMath. So you do that, you secure a graduate role again, but this time you've got some exemptions. Can I remember I said that you have 6 or 7 exemptions. 6 is for the BSc, and then on some MMaths, such as the one which I teach, we actually have another exemption on top of that. So potentially 7, and of course that leaves only 6 or 7 exams for you to qualify. So of course that cuts down your time for qualification, which is really important. The profession has been very keen to try to encourage actuarial science degrees, so then people can qualify a little bit quicker. 5 to 7 years is quite a long time. 2 to 4 years is long, but less than the 5 to 7. So that's why they're pretty keen. And as I say, there you're qualified. There is the spiritual home of the Institute and Faculty of Actuaries. It's called Staple Inn, and there's the garden. All them good actuaries there. Looks like some newly qualifieds there. Nobody standing on the grass. All very good, except that young lady there, I think. Okay, so how much can you earn? Well, it's a very rewarding career being an actuary, not just financially, but the responsibility you have and the interesting tasks you do is huge. So you join the profession once you finish university. Typically, you're going to be earning between 30 and 50,000. You qualify, and that goes up to your newly qualified salaries are probably well over 50,000 now, towards the top end, 75. And then from then on, like any business, as you progress, you start to get paid quite a lot of money. And chief actuaries can be paid, often sitting on boards of insurance companies, or even if they're not chief actuaries, they're very senior actuary, and they're senior managers working for other financial firms. They can, they're on the board, they can be paid huge numbers. So it's a financially very rewarding career. And what sort of firms can you go and work for? Well, as an actuary, Lloyd's of London, Tesla. So we can see we've got, Lloyd's of London started in the late 1600s, I think, something like 1680. So you can work at really old firms, and then you can work at these amazingly new firms, such as Tesla. PwC, Accurate there is a new startup which is focusing on machine learning and actuarial. Amazon is thinking about employing actuaries. Aviva, of course, BlackRock. It's worldwide skills. So, in summary, for today, actuarial science is demanding. It's not a walk in the park of a degree. It is tough, but it is rewarding, and you start to see that with them last slides when I talked about being an actuary, for example. There's lots of universities that offer courses, so that allows you to pick where your interests are. Some people just want to go to a course close to their house, which is great, but others want to, really specialize in a particular area, such as, data science or something, and certain courses will be more wedded to that. Excellent career prospects. Hopefully you can see that. And, you should do further research. Start on the IFOA site. Have a look on there. It's a really good site for you to get further information. So that's me finished. I hope you find that helpful.